Hi everyone, this is section 15 in our course. Hold on, I forgot to select my pen here. So this is section 15. And we have a very short lesson, prep skills, in this section. We have two. We have recognize multiplication as repeated addition and compute percentage of a whole. So, recognizing multiplication as repeated addition, they have 7 plus 7 plus 7 plus 7. So all they want us to do is to remember in this case that when you have 7 added multiple times, that we could, instead of adding 7 plus 7 plus 7 plus 7, we could take 7 times 5, because that's literally what 7 times 5 means. 5 times 7 means 7 5 times. 5 times of 7. So that's what that means, and it's equal to 35. Same thing with negative 4 times negative 4 times negative 4 times, I'm sorry, not times, plus negative 4 plus negative 4 plus negative 4. That's the same thing as 4 times negative 4, because we have 4, we're adding negative 4 times. And so 4 times negative 4 is negative 16. The next skill is just computing the percentage of a whole, which we've actually done a little bit. We're back on lesson 1.3 in the book that we're getting a lot of our material out of, and in some later lessons we'd already kind of done this, but just as a reminder, if you want a percentage of a whole, of in math almost always means times, and so 40% of 100, that one's kind of straightforward because we already know 40% means out of 100. So 40 out of 100 of 100 is going to be 40. But if we didn't know that already, you could change 40% to 0.4 of almost always means times and then 100. So 0.4 times 100 is 40. Same thing for this one. If we want 5% of 30, we change 5% to a decimal, 0.05. Always shift it over 2 spots. And so we take that times 30, because we want 5% of 30, and that would give us 1.5. So now this is a time where you want to pause this real briefly, work through these problems, and then turn it back on. So go ahead and pause and do 1 A and B and 2 A, B, C, and D. Okay, so if you've done these problems, hopefully on this one you saw that that was 10. And so that's 6 times 10. And honestly, if you wrote 10 times 6, that would be okay also, because multiplication is commutative. So if you want to think of it as 10 6 times, or it's 6 times of 10, they both will get you the same answer, because that multiplication is commutative. This would be 1, 2, 3, 4, 5 cases of negative 3. So 5 times negative 3, or again, that would be the same as negative 3 times 5. And this first one would give us 60, of course, and the second one, negative 3 times 5, would be negative 15. So that's what you should have gotten for those, and you should have written it as a multiplication first. On these problems, 50% of 84 would be 0.5 times 84, or half of 84, which is 42. I'm sorry, 42. 35% of 200 would be 0.35 times 200, which would be 70. 4% of 1,000 would be 0.04. Remember, you got to shift it 2 spots. Don't just write 0.4. That'd be 40%. We only want 4% of 1,000. That would give us 40. And then 11.3% of 550 would be 0.113 times 550. Remember, if there's no operator between a number and a parentheses, it means there's a multiplication there. So 0.113 times 550, I didn't have this one worked out, sorry, so this is 0.113 times 550 would be 62.15. So that's it for our prep skills. So we're going to pick up with the class and group and application problems. And to finish up section, again, what is in our book, section 15.
These questions are actually kind of personal. You need to think about how they relate to your own life. So hopefully you've already gone through and thought about your responses to these questions. So what I'll do now is go through and talk about what we hoped you would get out of this. In number 1, write about a time you put off something that you had to do and then regretted it later. Hopefully what this reminded you of was the idea that procrastination is usually not a good idea, and you can end up not having enough time to get things done or not enough time to get them done well. And number 2, write down an activity that you're good at and think about how good you were when you started as compared to now and the time that went into building that skill. Well, math is like other activities. It requires practice to improve. You may not feel like you're really great at it right now, but with practice and time, you can improve. In 3, it asks you to think about a task you've performed that required different small steps to accomplish something bigger. The idea here is to think about how when you have a lot to do, especially a large homework load, breaking it into smaller pieces is helpful. It's a good idea to work on a little bit every day. And in 4, what do you do when you're overwhelmed with work and need to develop a plan? Well, step back, write down what needs to be done, and then think about how to break that up into manageable pieces. In 5, we're asked, if someone buys 2 cups of coffee at $2.45 a piece every day, how much does she spend in one full year? Well, first of all, $2.45 each times 2 cups a day is $4.90 a day. And then there are 365 days in a year, so $4.90 times 365 gives us $1,788.50 per year. Now 6 wants us to think about that calculation. There are 2 ways to do it. I could have added up $4.90 plus $4.90 plus $4.90 and so on until I got up to 365 days. Or I could do what I did, which is just multiply $4.90 times 365, which is much quicker. In 7 then, what's the relationship between multiplication and addition? Well, multiplying a number is the same thing as adding the number that many times. In 8 then, let's think about that same person who's buying 2 cups of coffee at $2.45 a piece, and how much will she spend after one day? Well, we figured that out already. $2.45 times 2 cups of coffee comes out to $4.90 per day. Well, then we can use that $4.90 a day to answer after 3 days. She would spend $4.90 times 3. So after 3 days, it's going to cost her $14.70. How about after 10 days? Well, $4.90 times 10 equals $49. And then after 180 days, $4.90 times 180 comes out to $882. In 9, how much would she save over the course of a year if instead of buying the $2.45 cups, she bought them at another location that sold coffee for $1.49 per cup? Well, first of all, if she's spending $1.49 per cup times 2 cups a day, that's only going to cost her $2.98 per day. So now if we want to know what that is over the course of a year, $2.98 times 365 days, now it comes out to $1,087.70 for a year. So then how much does that save her? Well, when she was buying the more expensive cups, it was $1,788.50, so we can subtract this new lower price, $1,087.70, and that comes out to a $700.80 savings. In 10, Tommy and Gina are saving for retirement. They're starting with $1,000 and then depositing $100 every month for 20 years. How much will they have at the end? Well, first of all, $100 a month times 12 months means they're saving $1,200 a year. That means that over the course of 20 years, they'll save $1,200 times 20 years, and that comes out to $24,000. But then don't forget that they started with $1,000. So we're starting with $1,000. Over the course of the 20 years, they're adding $24,000 to that, which means they'll end up with $25,000 in the end. In 11, we're going to look at that same situation over different lengths of time. So after 1 month, they have the original $1,000, plus they've only made one $100 deposit. That will give them $1,100. After a year, they've started with that $1,000 and they've deposited $100 12 times. So 1,000 plus 100 times 12 gives me $2,200. After 5 years, they still started with the 1,000 plus that $100 times 12 months would give them 1 year's worth of deposits. I need 5 years, so I'm also going to multiply it by 5. That comes out to 7,000. And then after 10 years, same idea. They start with $1,000 plus $100 per month times 12 months a year, this time times 10 years, and that gives them $13,000. In 12, how much more could they save in 20 years if they deposited $125 each month? Well, the calculations would be similar to number 10. We'd have $125 a month times 12 months, which means they'd be saving $1,500 per year. And then over the course of 20 years, that would be 1,500 times 20. And that means that they would be saving $30,000. But again, don't forget the original 1,000. So they started with 1,000 and they added 30,000 to it. That means now they'd end up with 31,000. If they had only saved $100 a month, they would have saved 25,000. So this is an extra $6,000. Here we're given 2 pie charts. The first one illustrates the percentage of energy consumption in the U.S. by energy source for 2014. In number 1, it points out that this pie chart shows that 35% came from petroleum. The total energy usage for the U.S. in that year was 98.3 quadrillion BTUs. What does the result then of 0.35 times 98.3 tell us? Well, that would be finding 35% of the total. So that would be finding the amount of energy that was generated using petroleum. When we multiply that out, we get 34.405. Remember, these are in quadrillions, so that's quadrillion BTUs generated using petroleum in that year. In number 2, does the calculation 98.3 times 0.35 have the same result? Well, yes, it does. It also comes out to 34.405. This tells us that with multiplication, the order doesn't matter. Multiplication is commutative. In number 3, how many quadrillion BTU were generated using renewable energy sources? Well, renewable energy was 10% of the consumption that year. We've already been told that the total was 98.3, so we can do 0.10 for 10% times 98.3, and that's going to give us 9.83 quadrillion BTU. In number 4, we're asked about wind power and solar power. Well, looking at the second pie chart, that's the breakdown specifically of the renewable energy sources. So out of that 9.83 quadrillion that we found in number 3, wind power is 18%. So we can do 0.18 times 9.83. And that gives us 1.77 quadrillion BTUs. Then looking at solar power, that is 4%. So we'd have 0.04 times 9.83, and that comes out to about 0.39 quadrillion BTUs. In number 5, we're looking back at the first pie chart at natural gas. And so we're asked, what is the significance of the calculation 100.8 divided by 360? Well, if we do that calculation, we get 0.28. That is the percentage that was consumed by natural gas. 360 are the number of degrees in a circle. So that means that the 100.8 was the number of degrees for the natural gas slice. And then number 6 asks, does 360 divided by 100.8 have the same result? Well, no, it does not. That one comes out to 3.57. So that tells us that with division, the order does matter. Division is not commutative. In 7 through 9, we're picking out the word that tells us which arithmetic operation to use. So in number 7, the product of 20 and 250, product means multiply. So we'll do 20 times $2.50, and that comes out to $50. For 8, last year I made $2,000 working part-time, but this year I made 3 times as much. So the word times also tells me to multiply. So I'll do 2,000 times 3, and that gives me $6,000. In 9, the quotient of $24 and 12 gallons. The word quotient tells us to divide. And so $24 divided by 12 gallons gives me $2 per gallon. In 10, now we're going to summarize the words we've learned for the different operations. So for multiplication, there's multiplied by, and then we have now learned product and times. For division, you can say a number over another, you can say divided by, and we have also now learned quotient. In 1, if you spend 30 minutes a day on the internet, how much time do you waste over the course of a 16-week semester? Well, that's 30 minutes a day times 7 days in a week, and that tells us that you waste 210 minutes a week, but then over the course of a 16-week semester, I need to also multiply that by 16. And so that comes out to a total of 3,360 minutes. Now they asked for the answer in both minutes and hours, so I can divide that by 60 to get 56 hours. Then they want us to do that again for 45 minutes. So same idea. 45 minutes times 7 days tells us how many minutes we waste in a week, and then I need to multiply that by 16 weeks. That'll give me 5,040 minutes over the course of those 16 weeks. And then to convert that to hours, 5,040 divided by 60 comes out to 84 hours. In number 2, we have a guy, George, who weighed 160 pounds at the start of college. He gains a quarter of a pound a month for the 4 years of college. So how much will he weigh when he graduates? So he started at 160 pounds plus a quarter of a pound per month. Well, then we need to think about how many months are in 4 years. So off to the side here, 4 years times 12 months in a year gives us 48 months. So that's what I need to multiply that 1/4 of a pound by, because that's what he's gaining per month. And that comes out to 172 pounds. Now, how much will he weigh if he continues to gain that after his 10th college reunion? So now he weighs 172 pounds plus 1/4 of a pound for 10 years. So in 10 years times 12 months, there are 120 months. So that's what I need to multiply the 1/4 of a pound by. And that comes out to 202 pounds. In number 3, to lose a pound of body fat, you need to burn about 3,500 calories above what you take in. So if you burn 450 more calories than you take in each day, how long will it take to lose a pound? Well, we need to know, if we're trying to burn a total of 3,500, how long will it take at 450 a day? So we'll divide that by 450, and that tells us that that would take about 7.8 days. What about 10 pounds? We can take that answer, 7.8 days to lose 1 pound, times 10, and so that'll be 78 days to lose 10 pounds. In number 4, an average-sized person burns about 350 calories in an hour of walking at a fairly brisk pace. How many calories would you burn if you walk an hour a day for 6 months? So 350 calories per day for that hour that we're walking, times how many days are in 6 months? Well, that's half a year. So if there are 365 days in a year and 6 months is half a year, that comes out to 182.5 days in 6 months. That's probably the best estimate we can get, because every month has a different number of days, so this would be a good average. So 350 calories a day times 182.5 days gives us 63,875 calories. Now, the next question then is, how many pounds of body fat would that correspond to? Well, we'll take the 63,875 calories and divide it by the 3,500 that we know it takes to burn a pound of body fat, and that comes out to about 18.25 pounds. In 5, the figure below is made up of smaller squares. Calculate the total number of small squares 2 different ways. So first we're going to do it using addition. Well, if I'm going to add, I'm going to first count up how many are in each row. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in a row. And so I'll do 10 plus 10 for the second row, plus 10 for the third row, plus 10 for the fourth row, plus 10 for the fifth row. And so that'll come out to 50. Or I could do that with multiplication. I could say I have 10 in a row times 5 rows, and that would also come out to 50. In 6, why do you think the size of a two-dimensional object, like this rectangle, is measured in square units? For example, like square inches, square centimeters, whatever. Well, it's because the size of that object is measured by counting how many little squares fit in it. In 7, now let's look at 3 dimensions, and again we'll do it both using addition and multiplication. So for this one, I think for addition I would first count how many were in a layer. So I'm going to look at this top layer here, and that's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blocks in that first layer. So 12 blocks for the first layer, plus 12 blocks for the second layer, plus 12 blocks for the third layer, gives me a total of 36 blocks. Then for multiplication, I could say, well, there are 12 in a layer times 3 layers, and that also comes out to 36. In 8, if each of the cubes is an inch long on every side, what units do you think you would use to measure the volume? Well, we're counting how many little cubes fit in it, so we would probably use a unit related to that. In this case, if they're all an inch long on every side, we would probably call it a cubic inch.